Okay, so we are on question number dose, correct? Yes. All right, so it says here, the cost C, not right now. The cost C in numbers of cents per kilometer of operating a car is a function of the speed in kilometers per hour at which the car is driven. The relationship is represented by the following function. Okay, C equals 100 S squared minus S plus 37. Okay, so we're going to graph, find the domain and range that would help us be in the first quadrant, and then we're going to analyze and answer the following questions. Cool. All right, so we're going to go to Desmos, and we're typing in so I can see. I printed it out. Instead of using S, we're going to have to use X. So we have 0.01x shift 6 x squared minus x plus 37. All right. So when I come over here, I can't see it. So before I go to the setting, I'm going to try and see, can I zoom in or out before? So I'm going to zoom out. And as I zoom out, does my picture start to form? Yes. I love it when it happens that way. You're like, look at my graph. Okay. So your domain and range for real world events typically take place in quadrant 1. So when we're asking for the domain and range, we're talking about the domain and range for this particular real world problem. So in this case, our domain and range, we are analyzing the points within quadrant 1, right? So in quadrant 1, what is the domain? Where do my x's begin and end? 0 to, well, it goes beyond 50, right? Because it's actually still going in quadrant 1. Do we see that? So in theory, it could be 0 to infinity. We don't know where the speed stops or how far, or how long. So we go from 0 to infinity. Okay. And then looking here, what is our range? What is our lowest y value to our highest y value? 12 to infinity. Good job. So I'm going to create a little sketchy sketch. So we're here at, what was it, 0.37. And we're down here at 50,20. Okay. So it asks us, how much would you spend to drive at 150 kilometers per hour? Okay. So what this is asking us is what? Are we talking about our independent or dependent variable? Meaning, are we talking about the X or the Y? So it says, how much would you spend to drive at 150 kilometers per hour? Yes, what is the 150? It is our X. And we can read back in the problem. It says your cost is your dependent variable. This is our C. So our X represents our C, and that is our cents per kilometer, right? So cents per kilometers. Okay. Our speed in kilometers per hour. So our X-axis represents our speed in kilometers per hour. So if they gave us kilometers per hour, that means we're looking for the Y, our cost. So we're looking for the cost for 150. Okay, and there's a couple of ways that you can solve this. We're going to talk about way number 1. Again, way number 1 is I literally am just going to substitute in 150 for x squared, right? For x. So we have 0.01 times 150 squared minus x plus 37. Nope, not x. Y'all just gonna let me write it too. 150. And what do we get? 112. Do we see that? Okay, your other option is, it's a little finicky, but your other option is to use your graph. So if I zoom out a little bit more, notice how I have 150. I can follow 150 and try to kind of like get in a gauge of where 150 is, and it'll tell me 150 is 112. Now, are all graphs this friendly? No. That's why we don't want to forget our basic skill of just substitution. Does that make sense? Yeah? All right. Show if I was to drive 150 kilometers per hour, it would cost me 112 cents per kilometer. Well, that's cents. What's the symbol for cents, guys? It's a little C, isn't it? But that thing? Yeah. 112? 112. Oh, let it be. It just happened. All right. Now it says between two speeds, which two speeds must you drive in order to keep your cost to no more than 20 cents per kilometer? Okay. So this time, this is your what? 20 cents is going to be your what? Your Y, right? So in this case, our C is less than or equal to 20, right? I wrote that greater. I said the right words, wrote the wrong. C is less than or equal to 20, okay? How we're going to do it in the calculator is, that means on our y-axis, we want to know when we're at 20, pretend that's the straightest line you've ever seen. It's horrible. I can't even pretend today. We're looking for this value and that value. Does that make sense? All right, so how it works on the calculator is we're literally going to say we want to know when y equals this. So we're going to type y equals 20. Yeah, we typed in y equals 20, and guess what it tells us? It tells us where y equals 20. Do we see that? Anyone needs help? Me come around? Yeah? Nobody, no questions? Is this good, no questions, or? Okay, we'll come back to that, but we're here on Desmos. That means. Okay, so we're between x's, our x values, our speed has to be between 21.716 and 78.284 for us to stay at 20 cents per kilometer. So there's two ways of writing this. You either can, your answer choice may want you to write it as a inequality. So our speed has to be less than or equal to, and what was our lowest speed? 7 what? 16? And then what's our fastest speed? 284. Okay? Or this is an inequality notation. It can be written in interval notation just as 21.716, comma, 78.284. Was that terrible? It was. Oh no, typing in those 4 characters on the key injured my hand. Oh, I'm so sorry. You probably need a good hand massage right now. All right. It says, what should you drive to have the lowest cost per, sorry, this should have been kilometers, per kilometer. No, what should your speed be? What is our speed? What's my lowest? So keyword is lowest, which means I'm looking for my minimum. So what? Or so 50. So looking at our graph, where's our minimum? 50. So we would need to drive 50 kilometers per hour. And the cost would be 12 cents per kilometer. So if we drove at 50 kilometers per hour most of the time, that's how we'd be the most efficient in our vehicle based on this vehicle's data. Okay. Kind of. All right. So the last part of this for 3.3 G part 1 is we're going to do a little review. Huh? There's a back. Is there not a back? Yeah, there's a question on that. I don't know why you don't have a back. That's weird. I'm sorry. There's a back though. It's gonna be a little quick. I feel like we needed a little more practice with just regression models. Mine looks really yucky, and I don't know why. But on the back of yours, you should have this regression model with this function. No, I can't. It's all right. So right here, it says a farmer collected the data below showing crop yields for various amounts of fertilizer. So what the farmer recognized is that, okay, I'm adding fertilizer. And when I add fertilizer, I get more bushels. But hold on, I added this fertilizer and then my bushel count started to go down, right? So he's analyzing what's happening to his crops. And so what we're going to do is we're going to make our scatter plot. So how do we make our scatter plot in Desmos? No, we have to add a table. So we're going to add a table in Desmos. And then we're going to analyze the scatter plot. And so we're going to analyze the scatter plot and look and see what are these points doing to get our best model. Okay. All right. So I'm going to go here. We're going to start fresh. So I hit the 3 lines. I'm going to get a new blank document. And I'm going to add a table. After adding the table, I'm going to type in my values. So we have 0, 5. And the good thing about Desmos is once it realizes that you're counting by a certain amount, you can just hit enter and it will add the rest of the values in for you. So now I'm going to add my Y values. 4, 10, 12, 15, 18, 20, 21, 21. I skipped something.
How do you do that so fast?
I'm typing. 4, 10, 12, 15. Oh, I have an extra row. 19, and I need to delete 45. All right. Okay. So all of my things are in. Now it says, look at the graph and say what best model is it. Well, can I see all my points? No. So I can't see all my points. So I'm going to zoom out. Can I see all my points now? I had to zoom out. All right, looking at what we have here, what is happening? It's going boom, boom, boom. So what do we call that? A quadratic. We have an upside down parabola happening here, right? So it says, based on the scatter plot, what type of function do we have? We have a quadratic. Okay. Zoom out on your graph. It's probably already there. So we're going to, since we have quadratic in Desmos, we're going to use the standard form of quadratic in Desmos. That's our Y sub 1. The line, the squiggle, I cannot say what it's called. AX1 squared plus BX1 plus C is what we're going to type in next. I don't know what it's called, but it's an approximation, not an equal. So it's telling them that we're creating a regression. So we're finding an approximation. All right, so I'm going to go to Y2, and we're typing Y1 squiggle by pressing Shift. You just type Y and 1. Then we're typing AX1. And we're going to hit Shift 6 to square it. Plus BX1 plus C. Okay. So to get your power, it's Shift 6. And it says this is the best fit we can give you. So in Y3, we're going to write out our equation. So our equation, it tells us the value of our A, the value of our B, and the value of our C. We're gonna round to the nearest 3 decimal places, okay?
Just press one. You said that was it?
We're gonna type it in. So we have Y equals. What's the value of our A? It says A is negative 0.015. X shift 6 squared
Hold on, what? 25.
plus, what's our B? 1.007 X plus our C, and what's our C? 4.206. Okay, notice that the graphs that we typed in do not line perfectly up. That's because we rounded, whereas the formula above is the most exact approximation.
Okay,
Yes.
it ain't on there. Okay, isn't that something different? Wait, what did I do? Why is it doing?
Okay, I will have to, I don't know what y'all are doing
No,
differently.
it's not. Why my top line is on top of yours? Like it's. I don't know. I'm gonna.
Try to problem solve before you just throw the laptop.
Oh, because then I have a black line, and my black line is your red line, your red line.
Okay, see, look at that. All right, so that's the answer. So it says, what is the equation that best model? We made our equation. So it says, find the function of best fit. That's our function of best fit.
Wait, how you do that?
Do what?
What you doing?
What do you mean? I'm on a computer.
Oh.
I'm on a computer.
Yeah.
Okay, where we lost that? Did we not write the function?
Really, I think. No, you have to put a 5 on it. I think it's either skipping on it, like, I don't know.
I see confused faces. I need to know where and why we're confused.
Okay.
Okay. All right, so we found it says find the function of best fit. We found our function of best fit. Now it says draw the function on the scatter plot. I can't do that because you see mine is a little confused. But you can, and we can analyze your domain and range. So in quadrant 1, our domain, I like to, once I have my plot, I delete this one because I don't need it anymore. It just seems like too much on the screen for me. You can keep it if it doesn't bother you. But I'm analyzing from here, the regression model,
Oh, the Y.
the Y squiggle. Yeah. So now I'm analyzing this. So what is the domain here? 0 to what? 71.078. Do we see that? So it goes from 0. So X's start at 0, but they end at 71.078. So that's my domain. So we're gonna write our domain. So we're from 0 to 71 point, can't remember, 078. Okay, our range. Range is from bottom to top. So our lowest Y value is, but our highest Y value is 21.107. So we're at 0 to 21.107. Okay. Then it asks us how much fertilizer should be applied for maximum yield. So keyword here is maximum yield. So we're looking for our maximum. Where is our maximum? Right here. Look at that. So how much fertilizer should the farmer be using?
3.3.
33.57, 567, 567, 57, 33 and 57 hundredths pounds of fertilizer. So that's the sweet spot for him. Well, we wrote it. We typed it in underneath our regression model.
No.
Yeah, we did.
Okay.
Hold on. So our maximum yield. So from there, I'll yield about 21 and 11 hundredths of bushels. So that's gonna be, oh my gosh, I just didn't want to write another. Bushels?
Oh.
Is that how you spell it? Yeah, bushels. Bushels. It's there. Right there. Bushels. You get it. Yes. All right. Okay. Is it terrible in Desmos? How do we feel about Desmos?
Sorry. Are we done?